Welcome to Brain Vision.
Well, in special theory of relativity, this is completely sound and understandable. Since the sandwich is oriented such that it is its length in the direction of motion, hence it would exhibit a length contraction. So the sandwich will exhibit length contraction. Length contraction, because the sandwich is oriented such that its length is in the direction of motion. So its length is in the direction of motion. In the direction of motion. Okay. Now let us look at the sandwich with respect to two observers. Well, the person in the train would measure the sandwich to be 1 foot in length. So the person inside the train, so observer inside the train, measures the sandwich to be 1 foot in length. 1 foot in length. But for an observer outside the train, right? So, but for an observer outside the frame of reference, let's say an observer standing on the station, the observer observe that this sandwich is much smaller in length. Whereas the faster the train is going, the shorter the sandwich appears to the ground observer. So to the observer on the station or on the ground, the sandwich is much smaller in length. So the sandwich is much smaller in length due to relative speed. Okay, well, where the observer eating the sandwich, the observer inside the moving train would measure the proper length, while the observer on the ground would measure the relativistic length, and the two lengths are related by L is equal to L prime divided by gamma. Here gamma is the relativistic factor which is always greater than or equal to 1. So gamma is greater than or equal to 1. When the train is stationary, then the Lorentz factor is 1. The faster the train goes, the higher the relativistic factor, and the shorter the sandwich appears to an external stationary observer. So in short, relativistic length is inversely proportional to the Lorentz factor. So the relativistic length L is inversely proportional to the Lorentz factor. Now similarly, let's talk about the time. Well, the relativistic time and the proper time are related by delta t is equal to gamma times delta t naught. Well, we find that this time, unlike Lorentz contraction, the relativistic time here is proportional to the Lorentz factor, which means that greater the train goes, the longer is the time interval in which the man inside the train finishes his sandwich from the perspective of an observer on the ground. So thus the man would finish a shorter sandwich in a longer time. So shorter sandwich uh, in a longer time, in a longer time interval, time interval, interval. Okay, and this is from the perspective of a stationary observer, and that's the correct